So electric potential is what? Electric potential is, it basically defines electrical properties around a charge in scalar form. So whatever you have studied regarding electric field, that a force is exerted by a single unit positive charge, everything what you've studied about electric field, that was in vector form. If you write everything which was in vector form in terms of scalar form, that becomes potential. So it's just, it defines electrical properties around a charge in scalar form. Everything remains the same. Source charge is also present, test charge is also present, and its property of a single charge, the way electric field is also property of a single charge. Means for exertion of force, you need to have two charges, right? But for exertion of electrical field or for exertion of electrical potential, you just need to have an isolated single charge. All right. Then this is a very basic formula. V is equal to W divided by Q. But remember class, though it's a very small formula, but its integration and a little more details about work done can make this question complicated. So how can complications be there in this question? Work done which is present, no. It can link this work done with the work done which you have studied in class 11, chapter 5, right? So firstly, you have to identify work done and apply the whole concept of work done from that, divided by the charge, that will give you potential. And charges modification is usually not done in your exam. Charges are directly given simply, or using Q is equal to NE, number of electrons to electric field. Using that, it is given. Electronic charge that is given. Otherwise, charges are direct, very simple. But work done is usually related with your work energy power. So all your conservative forces, non-conservative forces, work done by a single body, work done positive, negative, zero, those concepts get applied. So whenever you're solving such questions, do take your mind once if directly nothing is given. All right, so this is electric potential. Definitions, need not do now. Derivations also are not very important. Just remember it's a scalar quantity. So if you are getting it as positive, directly add it or subtract it for negative charges. So plus minus like this. All right, so electric potential for a system of n number of charges, that's what is superposition principle. For positive charges, keep on adding it. For negative charges, keep on subtracting it. That's it. And nothing else is important. Otherwise, you just have to manage the questions which come. Then potential of dipole. Dipole, I think we took a single class for dipole only, because dipole is very important from your entrance perspective. Because when we get a question of dipole, no, it doesn't involve only the one single concept of dipole. It has so many concepts lying behind it, right? Electric field also gets involved, potential also gets involved. So when a single dipole comes, it doesn't usually have its own. All right, so learn the general formula, because equatorial is already zero and axial is also very simple formula. Learn this general formula, and that too the generalized one, not with ideal dipole approximation. All right, so R is very, very much greater than A. R square minus A square cos square theta. This is approximately equal to R square. So use ideal dipole approximation when it is needed, but usually the questions have Kp cos theta by R square minus A square cos square theta. So for your JEE entrance, this formula becomes very important out of all the formulas that are present. Usually these are important from your board's exam, right? So Kp divided by R square. Otherwise, what can happen? Statement based question can be there, which can use both of these. The formula also, as well as the concept of equatorial field. All right. Then yes, class, this relation is very important. E is equal to minus dV by dr. This was important earlier as well when you were doing in terms of board examination also, and for your entrance also this is important, because this doesn't get used directly. Like you will not be having a very simple potentials formula and you just need to differentiate it and you will get electric field and the final answer will be decided. No, this will be used so indirectly that wherever you will be needing electric field in your solution, you will differentiate potential with respect to position and you will get electric field and further use electric field in your question to get whatever is your answer. So this has a very small formula, but a very bigger impact on your final solution. So it's potential gradients, and yes, from this topic, your statement based assertion reasoning type question. Statement 1 is true, 2 is true, 1 is the correct explanation of second. These types of questions do come from this part. So this is also very important. More than that of axial and equatorial field, this partial derivation part, this is quite important for all of you. Then potential equipotential surface. Again, from equipotential surface, direct statement based questions are asked. If the direct application based statements will be given to you. So from equipotential surface, usually you do not have numericals from this because work done directly becomes zero. So from equipotential surfaces, you will be having theoretical questions. And this electric potential energy is very important because from your electric potential energy, questions have been coming in the last 2 to 3 years. So we'll also see some questions from this topic today also in today's class. It's a very, very small topic, but electric potential energy is also important. See, for electric potential energy, I think one concept we used in the earlier class as well when you're doing electric charges and field. For you do not have to go into the details of it, the derivation part. Just remember, this is the generalized formula. K, that is 9 into 10 to the power 9. Q1 is the first charge, Q2 is the second charge, and R is the separation between both the charges. Find K Q1 Q2 divided by R. So two charges are present, K Q1 Q2 divided by R12. Then you will be having again two types of charges. Let's say three types of charges are existing. Instead of learning the whole derivation, no, just learn it in this way. Suppose I have two charges, Q1, Q2. Their separation is R12, so I'll use this formula. Suppose in nature I have one more charge, Q3. So how many interactions? You will count the number of interactions. One will be between Q1 and Q2. So you will use this. Then between Q2 and Q3. So you will use K, Q2, Q3 divided by the separation between 2 and 3. Then Q1 and Q3. K, Q1, Q3 separation between Q1, 3. Add it or subtract it depending upon the nature of charge. If it is negative, put negative. If both are negative, that will become plus, like this. If both are negative, that will become positive because here they are in multiplication. Like this, added. This is what you have to use for potential energy. Even if you have one more charge, then you will count the number of interaction. One will interact with 4. Then 2 will also interact with 4. 3 will also interact with 4. And apart from there, the intra-interactions within these, like this. So basically, you have to see wherever potential energy is asked, no class, wherever. See, for kinetic energy, remember this trick, you will have to apply the concept of velocity and motion. But for potential energy, wherever you're seeing that two things exist, as in two masses exist, both the masses also can exert force on each other, so you get gravitational potential energy. Two charges also exist, so both the charges can exert force on each other, so you get electric potential energy. Likewise, so just count the number of interaction, use this as the generalized formula, K Q1 Q2 by R12. All right, just use this as a generalized formula. Once you use this as a generalized formula, whatever is it given, if one is minus Q1, another is minus Q2, you will subtract it. If both are negative, then that will become positive. So Q1, Q2, you will add it, whatever is the whole formula. Like this. This is just one single trick, and the rest of it gets solved using this basic formula. Fine. So potential energy for n number of charges also, these were just important from your derivation part. See, like this. Q1, Q2 by R12, then work done by third one if a third charge gets added. Then one interaction with Q1, Q3 and Q2, Q3 also. Then for nth, you have this generalized formula for nth charge. Likewise, you have it. Yes, potential energy of electric dipole also, you can remember this is minus PE cos theta 2 minus cos theta 1. If you write this as positive, then make sure to write cos theta 1 minus cos theta 2. All right, because here if you reverse, since it's a negative sign present, the whole answer also shifts. So potential energy U2 is minus PE cos theta 2. Yes, class, when you have statement-based questions, no, do make sure work done by electric field is given or external force is given. work done by electric field and work done by external force, both are negative of each other. So sometimes you are given work done by electric field and you are asked to write the work done by external force, or vice versa happens. So just multiply it by -1, put a negative sign. Again, statement based questions do come from this part more than the numericals. Potential energy is minus PE cos theta. So if you put theta as 0 degree, that is potential dipole and electric field both are parallel to each other. So minimum value will be existing and it will be in stable equilibrium. Then maximum value is there, unstable equilibrium. Means when both are anti-parallel to each other, making angle 180 degree. And when the dipole is kept perpendicular to electric field, that is making an angle of 90 degree, directly you will say it is 0. So what all questions are important from this? From your theoretical questions that come in your JEE exam, the statement based questions basically in the form of statement 1 and statement 2 will be given, or a list of statements will be given and options will be in the manner option A, B, C are correct. Then statement A is only correct. Both the statements A, B are correct, like this. So you'll be given about information about stable equilibrium and negative value and this minimum value. Only these get related: maximum value, unstable equilibrium, and positive. This is in any ways 0. So from potential energy, these things are quite important. All right, let's see some numericals also from this part. Because numericals are important, I'll start with potential energies question only, because that is the most important. I'm writing question, write it, then try it. Whoever gets the answer, send me the option. If it's fill in the blank, send me whichever direct option you're getting it. Okay, yes, class. Any answers? It says that 27 similar drops of mercury are maintained at 10 volt each. All these spherical drops combine into a single big drop. The potential energy of the bigger drop is dash times than that of the smaller. So whenever these questions are given in terms of times, this mainly means that you have to take out the ratio. So number of droplets that are given, this is 27, and potential that is given, that is 10 volt. Fine. So see, which quantity remains constant when these 27 drops, they are combined to form a big drop? One physical quantity according to you that should remain constant is
Volume.
yes, Marita, right. This is volume. Volume remains constant. So it's actually 4 by 3 pi r cube equal to 4 by 3 pi r1. Let's write r1 as the drop of the radius of the drop. Fine. R is the, let's say, bigger drop and R1 is the smaller. R1 cube into 27 because it is 27 times, right? These 27 small drops, these are coalescing and forming one big single drop. No, that's why 27 times the volume of each is equal to the bigger one. So radius becomes 27 cube, R cube will become 27 R1 cube. So R will become 3 times R1. This is the relation. Now electric potential when you write. See, electric potential will be what? Directly if you write K cube by R square. Let's write directly the potential energy of the smaller drop. What all data is given? 27 similar drops were given, no? Yes, 27 similar drops of mercury, they are maintained at 10 volt each. So it means the potential of a single drop is 10 volt, that is already given. Fine. So what will be the potential now? Since it is 3R1 given, since it is 3R1 already mentioned, so that will become 3KQ by 5R, right? And also if you write the potential energy of all, because since the radius is becoming 3 times, that will also become 3 times. So potential energy for the smaller one, this will also become 3KQ1. And see, all the charges are also similar. So if you can even write this as Q1 into Q1, or you can write Q1 square. Okay, take 2 minutes then, fine. I'll wait. If you're getting the answer at this step, then okay, fine. I'll wait for 2 more minutes. Others also then send me your answer. This was the hint which you were seeking. No, Marita, just try it once again.
Okay, ma'am.
Okay, I think I should proceed with the discussion. If you get the answer by chance, you can send me in the chat box. All right. Whoever is completing, you can send me. So I was there with the energies, right? So I think we had did okay 3R radii relation we have done. So yes, radius is 3R. So what is the formula of potential energy? Right, we have to write the potential energy also for the smaller drop, also for the bigger drop also. So for the, if we write the potential energy for the smaller drop, so it is K Q1 square by 2R. If I write the general formula, I haven't put in anything. And same way, if I write about the bigger drop, that will be K Q2 square divided by 2 R1, right? R1 I think I have taken no for it. No, R1 is for the smaller one and this is R. All right. Now see, if you put in the values, Q2 is actually 27 times Q1, right? The final bigger drops one is 27 times the smaller one. And when you write about their radii relation, R is also three times R1. So when you substitute this finally, if I write it as U bigger by U smaller, this is going to be K into 27 Q1 whole square K 27 Q1 whole square divided by 2 into 3R, right? This R1, I'll write it as 3R. And then the denominator of this will also go 2 into R divided by K into Q1 square. So when you will solve this, the ratio bigger by smaller, this will be 243 times the smaller one. So when you have to write about the times, this would be it. I think those who were getting 9, they must have not squared it, 27. That's why you must be getting.
Ma'am, why 2R?
Because of potential energies, right? You are writing the total energy this time. Here you are considering the total energy this time. When we are writing potential energy is formula when you write the total energy. Q1, Q2 by 2 are this way we write, no? Ultimately at the end when you write, you just do not write that was for individual, first one. Remember the total formula at the end you get K Q1, Q2 by 2R. You have one kinetic energy, you have potential energies. Remember kinetic energy, you get minus K Q1, Q2 by R. Potential energy is K Q1, Q2 by 2R with a negative sign.
Yes, ma'am.
Okay. Okay, let me give you a very similar question to this one from your previous year's paper only. This is also a question of 2021. I'll give you one more question of 2021 only. Similar, it is based on similar pattern. Please try to give me the correct solution. Note it down first. Yes, Marita, correct answer. Your answer is right. Should I discuss or others are also giving me the answer? Krishna, Adriel, Aditya. This is easier than the last one. Yes, yes, Adriel. The second one which you have sent. No, that's right. Correct. Let me discuss it. I think this is all of you are able to. So what will be the relation? N is equal to 512 this time. And voltage is given 2 volt this time. All right. Now it means 512 into 4 by 3 pi r cube. That was a smaller number, 27. Is equal to 4 by 3 pi. I'm writing capital R for the bigger R, this much. So R cube will be equal to 502 small r cube, right? So R will be equal to 8 times R. This is the relation. So that since we are getting a larger area, that's why we will get a smaller number. Like all of those who are getting their answer, you must have seen it is the value is lesser than the value we are getting in the previous one. So general formula V is equal to KQ divided by R. Fine. Formula of potential is V is equal to KQ divided by R, and which is equal to 2 as well. So see, net will be what? How will you write potential for the bigger drop? K 512Q divided by 8 times R. So take the ratio V bigger by V smaller, K 512Q divided by 8R into 2R into R. If you write this divided by, what will there be left? KQ. No, 2 will also be there, no? Yes. So that will be 512 by 8, which will be 128 volt into 2. Yes. So 128 volt is answer. Quickly note it down, then we'll see some other question, not of this type now. Yes, Marita, your answer is right. Correct option.
Ma'am, we won't have to add all the values to check if V is equal to 0, right?
Even if you do it, because since 10 charges are given, you can take time for that. But in this question, 10 were given. No, it can happen more than 10 are given. 50, 100, 1000, then what will you do? Right, so you cannot add all the charges and subtract all the charges. So just apply one single trick that I'll tell you. Yes, Krishna, right. Yes, see others also. Option will directly be C. Here, if it is saying what it is meaning, what is the meaning of this when this is giving you in written form? No, easily if the figure would have been given, you would have got your answer. It's like this is a circle. Let's say this is some point, there's a center C. One charge is there. 4 charges are there. 5, 6, 7, 8, 9, 10. Like this, all the charges are present. If this is plus Q, this will be minus Q. If this is plus Q, minus Q, plus Q, minus Q, plus Q, minus Q, plus Q, and minus Q. When we talk about potential, C class, whatever you, let's say you'll get 4 kq by, let's say the radius is A, suppose 4 kq by A. So same way for negative charges, it will become minus 4 kq by A. It will be 0. So this is just an example by 10 number. You can write and draw it along this circle. If it is 100 charges, then will you be able to write it? Obviously not. You don't have so many time to write 100 charges, 50 positive, 50 negative. Right. If it is giving you an even number, when you have an even number, right, and this is present on the circle or any, especially it's a circle given. If it is even directly at the center, you mark it as 0. If it is odd, then whatever quantity, whichever one is the left out one, that will be the answer, because potential will be there because of it. This is just apply this. That's it. Since it was even, all will cancel each other. What about the electric? What about the electric field? See, electric field generated by this positive charge. Let's say electric field because of this positive charge. One is positive charge. This will be away from this charge. Fine. Just a second. One electric field will be there because of this positive charge. Let me write the positives together. But this is positive, positive, positive. This is positive. All these charges are positive. So all these charges are equidistant from the center. They are equidistant from the center. Fine. So they are and it is a symmetrical figure also. Class, one more thing, when this is a symmetrical figure, always at the center make electric field 0 without even calculating it. Fine, without making it by any calculations. So if it is equidistant, all will cancel one each other. Fine. So this is how you write. So that's why C option is correct. They have mentioned, they have
Ma'am, can you explain the odd case?
odd case. See, in the odd case, no, for example, and just one more thing. This is actually seventh, 9. Just make it out, no, whenever it is written alternate, successive, because till here your question is complete. Adriel, till here your question is complete. So even this was just a by mistake. This is a mistake from my side. It was mentioned in the question. So whenever it is written, no, successive charges or alternate charges, so directly assume it. Even it can happen in this question. It was mentioned 1379. Your question was complete till this part only, where alternate charges are having plus q and minus q sign. That is sufficient. When I'm seeing odd part, no, what will happen? Let's say there were 11 charges. One charge was left. Let's say one positive charge was left. So whichever is the whenever you have odd type of case, no, such type of case is given. There usually the chance is that that only magnitude is written. Likewise, here also, if you see the options here, minus plus, this is not mentioned because the magnitude is mentioned. Fine. So here also, suppose Q is left. So what will happen? Let's say this is A. So forget about rest of the charges. Just write what will be the potential because of this KQ by A. That's it. That's what you will write. If there is one more charge, that will again become even, right? If one more charge, so that one will remain odd. Both these will pair up. Like suppose 13. So 12 will cancel each other. One will be left. So always the answer will be due to a single charge. Left out means potential due to single charge. Clear?
Yes, ma'am.
Okay. Yes, Marita, right. Again, your answer is correct. Good. Okay, so I think till now, Marita's answer is correct. Rest of you, some due to some error, there must be an error. Adriel, your answer is also right. Adriel and Marita. Let me discuss it with you. See, potential for a charged sphere, this is what? KQ divided by R. What can we do? We can multiply and divide it by R. That is KQ by R square into R, or you can directly write electric field into radius, right? So V1 by V2 is what? E1 R1 by E2 R2, right? E1 R1 by E2 R2. This is what you can write. And what is E1 by E2 given? From the question, it is given to you R1 by R2. Right. So here you have your answer, option D. Put this V1 by V2 as R1 by R2 into R1 by R2. That becomes R1 by R2 whole square. Option D is right. No, Marita, try it again. Check your calculations. No, Adriel. Last 2 minutes and I'll discuss it with you. All right. All of you are getting option D. No, not B. Let me discuss it. Let me discuss this solution with you all first. Yes, Cedril. Now your answer is right. It's actually option C. See, it's like if I give you the figure of the circle, no? See, this is charge small q, this is charge capital Q. This is point P, which is separated by R by 2, and this entire is R. That's what is written, no? Electrostatic potential at a point P at a distance R by 2 from the center. This you have to find out, right? So C class, at P, due to the whole shell, due to this complete shell, no matter what, it will always remain KQ by capital R. Due to the whole shell, no, small q is situated outside. Where is small q situated? It is giving you thin spherical conducting shell. So potential due to the whole shell, be whatever is the radius, that's not of our concern. No, when we are talking about the whole shell, this is at P due to shell. Fine, the potential is KQ by R, right? And when we talk about this point, P due to Q, at P due to Q. When it says no, Q is located outside, it means this part only, in whichever language it writes. I think here is the issue where you all were getting. Now I think this must be correct. V2 will be what? V2 will be KQ divided by radius is R by 2. So R by 2. All right. Now you simply add it. What will it be? V net will become V1 plus V2. So that is Q by 4 pi epsilon naught R plus 2 Q by 4 pi epsilon naught R. So this was option C. Here, no, in the option D, you cannot take common, because if you take common, that means 2Q is also there. 2Q into 2Q, that is not correct. You're just having 2 along with capital Q. Note it down. One last easy question we'll see after this, then I'll wind it up.